All right, today we are solving word problems involving rate, time, and distance. So the purpose of today's lesson is really to apply our methods of solving systems to a real world system. So we're going to solve by substitution or elimination. All right. When we are looking at uniform motion, they call these uniform motion problems. There's three scenarios that happen. Two cars can be starting, or two transportation vehicles start at the same point, and they both travel to the same point. So it's kind of like a race, meaning their distance is the same, but their speeds are different, and likely their time is different. And in this scenario, it would mean that distance A is equal to distance B. The second one is when two distances start at opposite ends, and how long does it take for them to meet up? Okay, one's traveling faster, the other's traveling slower. And when they get to each other, we say that the distance of A and the distance of B together, if you add those up, it equals the distance of C. So it's A plus B equals C. The other situation is when two cars start at the same place and they're going in different directions. How long does it take for them to be 15 miles apart? So car A is going so many miles, car B travels so many miles. Together, the distance of A plus the distance of B equals C. Everybody should have this written down. Pause the recording and make sure this is written. Take a minute now and write the next question.
We write that down?
Okay, so when we do these word problems, I want you to sketch the actual diagram that we just used to determine what kind of equation this is going to look like. So it says two planes take off from the same airport at the same time. I'm assuming that looks like this. Okay, they're right at the same place. One travels east. I'm going to go the direction of the United States. So let's say this one is east and this one's going west. Okay, actually I'm going to make it a little bit more like this. There's a reason. So here's east and here's west. Why am I making that west longer? Because it's going faster. Right, so it's east and this is west. And then it says travels east and the other west, okay, at 200 miles faster than the eastbound plane. Find the speed of each plane if they are 2,000 miles apart after 2 hours. So what is this?
That's the C.
That's a what?
Between the miles.
What is it?
It's 2,000 miles. 2,000,
right? So this is just going to be an A plus B equals C, or an east plus west equals 2,000, right? It's going to be that kind. East plus west equals 2,000. Okay, using the boxes, what are we comparing? We're comparing east and west. They mentioned the word time. Miles is a distance. Miles per hour. This is a rate, time, and distance. So we have to use that formula. Rate times time equals distance. Okay? Now what can I fill in the boxes? Okay? We are going to walk this out. And what I want you to look for is what is the same or what is different. Because these things that are the same are implied hints that help you to solve this problem. So if Lily is the, let's say here's the United States. If you are the west plane and I am the east plane, who goes faster? Lily, the east, the west. Okay, so we're going to leave at the same time. She's the faster, so you have to walk faster than me. Okay, ready and set. And I want you to notice what is the same or what is different. Ready, set, go. And stop. Okay, what's the same?
You guys
The
both
same
moved.
time you guys left.
You guys both moved.
Okay, too much. Is the time that we moved, is it the same or different?
The same.
Okay, our distance,
Different.
our speed,
Different.
So the fact that the time is the same is kind of an implied hint. Now, sometimes they give you the time and then you put that in, but sometimes they don't. If they don't give you the time, knock it off. If they don't give you the time, then you get to use T for both. Okay? And so here we go. So in this case, did they give us the time?
Yes. 2 hours.
2 hours. So, and we're going to use that for both because in this scenario, they both traveled 2 hours. Do we know the distance of just the east plane?
Yes.
No.
No.
Yes, 200 more than west.
Distance. That's okay. Do we know the distance of the west plane?
No.
What distance do we know?
2,000.
The total distance. So we're going to need to add another here, and it becomes 2,000. Now, the rate. Do we know the rate of each plane? No. So we'll just call it R. But how do we differentiate their speeds?
R1 and R2.
Which one's plus 200?
West.
The west is the rate plus the 200. So now, just like we did before, we multiply across. I get 2R. This is 2 times R plus 200. And we do what going up and down? We add going up and down. And so here's our equation, which is 2R plus 2 times the quantity of R plus 200 equals 2,000. And now we've got 2R plus 2R plus 400. Don't forget to distribute. I'm having a lot of people forgetting that. A lot of people with issues with their negatives when they're... And then we have 4R plus, oops, that's supposed to be a plus sign, 400 equals 2,000. Subtract 400. And we get 4R equals 1,600. And R is equal to 400. So tell me, what is 400? Okay, Rami?
So 400 is the rate that east is going at.
I need you to use units now.
So 400 is the amount of miles per hour.
Right, 400 mph is the east. And then can we figure out the speed,
Add 200.
which is
600 miles per hour.
600 miles per hour? Now, everybody understands what a rate is, right?
Yeah.
What is a rate? Who
So
can?
it's like if you go this much, the other goes this much.
So it's like a ratio
Yeah,
of
it's-
comparing two quantities of different units. I'm gonna just put the real. I don't use W. I use R. Right? I don't like kids using X and Y. I'm sorry, I don't use X. I use. I want you using R and T and D because you're going to get a number, and I don't want you to be confused by what it is. Knowing that it's an R, we know it's so a rate is a comparison of two ratios with different units, right? We're comparing two miles per hour, right? So you can always tell a rate because it will have two units. We also call a rate the speed, right? And whatever you see as the speed, it will have two units, miles per hour. Like right here, this is a speed, miles per hour. Now, if you don't know if they don't tell you it's the speed, then you can figure it out if they say 2,000 miles in 2 hours. Then you know your speed is going to have to be miles per hour. Does that make sense?
Yeah.
All right. So here's the first way we solve it with one variable. The only difference, the only difference was Just sit. Just sit. Just sit. The only difference is I have you guys using R. Right? Everybody's clear on that? All right. I'm going to continue. Let's try this with two variables. There's some students, some old-time students. Let's see. We have Berkeley. We have Berkeley.
Why is your face like?
We have UCSB. We have SDSU, and we have Milligan. These are my students that used to be here one year that took control of my computer. And so now we'll get off of this because we've got word problems to do. Goodbye, kids. Shh. I'll explain later. All right. So here we're doing the same thing, only this time we're going to use two different variables. We still label it the same way. My time is still 2 hours, right? The difference is I'm going to call the east rate X and the other one Y. We multiply all the way across. I get 2X, 2Y. So equation number 1 is 2X plus 2Y equals 2,000. And then the other one you have to take out of the word problem as a translation.
Don't do that. Do also plus 200.
Just watch. West is 200 faster than east. So what do we call west? Y is equals 200 faster than east. X plus 200. Now, I'm going to take that and I'm going to substitute it in for my Y. So now I get here, it's 2x plus 2 times the quantity of x plus 200. What are we noticing? Well, it's more work, and it's also basically at the same point, the same equation.
You just skip the substitute step.
So 2x plus 2x plus 400 equals 2,000. 4x plus 400 equals 2,000. Subtract the 400. 4x equals 1,600. I'm dividing by 4 on both sides, and we get x equals 400. Right? So this is 400. And then to find the y, I'm going to use this equation. Y equals 400 plus 200. And we get y equals 600. It's never an either or. It's what you kind of naturally find yourself translating. You just need a way to translate it algebraically. I wouldn't say it's the universal policy that I always do it this way. Okay? All right, so that's with two variables. In this particular equation, I likely would not have done it this way. I would have naturally, intuitively used one variable. Okay, the next one. Karen leaves for work, traveling at 50 miles per hour. 15 minutes later, Mark chases after her with her briefcase, traveling 70 miles per hour. After how many minutes does he catch her? So I'm going to draw it. We can walk it out, but I'm going to draw it. Okay, let's call this Karen and this Mark. Okay, she's traveling 50. I'm just adding little pieces of information. And then Mark, he's traveling. Okay, what do we know about this scenario? Yeah.
I have a question.
What do I know about this scenario first? About Karen and Mark. He's going. I'm going to pause it for a minute. Okay, the question is, shouldn't his Mark be moved back a little? The situation, in order for him to catch her, they have to travel the same distance. The only way for him to catch her is they have to travel the same distance. So on the left side, what do I put? How do I label my box? The outside part.
Mark and Karen.
Good. Karen. And Mark. Okay, up top. First column, what am I calling it?
Rate. Time. Rate.
Time. And the last column?
Product.
Distance. Okay, so what can I put in here? What can we fill in? Yes.
For Karen, 50.
50 is the R, the rate. Good. The
50
speed.
R, and then 70 R for Mark.
Okay, somebody else. Now,
Is it just 50 or do you put 50 R?
no. We know the rate.
Okay.
Okay, hold on. Now, going back to it. Do we know the time?
Yes.
Yes.
Partially.
Do we know the distance?
Yes.
Yes.
Difference in it.
No.
Okay, hold on to time is more complicated, right?
Yes.
There's a difference in the time, so let's go to distance. Do we know the distance?
No.
But what do we know about the
We know that
distance?
they both travel the same amount of time.
The same distance.
Yes.
Same distance, not time.
I don't.
So we don't know it, but we know it's the same, so we can use D for distance. And so now we go to time. We don't know what their time is, so we'll use T. But how do we differentiate their T? Yep.
I think it says 15 minutes later, so Mark would be T minus 15.
Minus 15. But we're talking in hours. So you will need to convert that. There we go. How do I have to convert because I can't use minutes because this is in hours. So how would I how would I convert 15 minutes into hours? 15 minutes, yes.
T minus 1/4.
T minus, because 15 minutes is 1/4 of an hour. 1/4. So we could say T minus 1/4. So these are my two equations. 50T, remember we multiply across, equals D. And the other one is, I'm just going to say 70 times the quantity of T minus 1/4 equals D. Since they're both equal to D, I'm going to substitute. And we get
Why is it minus 1/4?
a fourth of an hour. 15 minutes is a fourth of an hour. Okay, so now I'm doing 70. I'm going to distribute. T minus 70 over 4 is 17 5/10 equals, I have 50T. Right?
Yes.
And then I'm going to, how about if I subtract 70T? And we end up with negative 17 5/10 equals negative 20T. Divide by negative 20. Divide by negative 20. T equals, what are we saying there? T equals, oh, that divides. Listen, this is like when I give a test, 17 out of 20 is 85%. 18 out of 20 is 90%. So this is exactly in the middle, so it's 0.875. Okay? Now, this is in hours. They're asking for minutes. I got to go back. So all I have to do is take that, it's hours, right? And multiply it by a fancy 1. Use our dimensional analysis that we did in Ms. Cacciatore's, which would be, remember, if I want to get rid of hours, since hours is in the numerator, and then I'm putting the minutes up here. What's the conversion of minutes to hours? 60 over 1. So all we really have to do is multiply it by 60. The hours cancel. 0.875 times 60 equals 52 5/10 minutes. And there we have it. Okay. Questions? Yes.
I'm so confused. When you have T minus 1/4, why would you take T minus 1/4?
Because if you're using mph here, this is miles per hour. Miles per hour. I can't use minutes there.
No, I mean, why would you do t minus 1/4 instead of t plus 1/4?
Because he's traveling 15 minutes less. He leaves later. They both travel the same amount of time, but he's minus 1/4 of an hour.
Oh, okay.
Right? Okay, go. Todd.
I'm sorry, I did not understand this, the parentheses.
I'm just converting. I just multiplied. I can multiply anything by 1, right?
Yeah, but that's a 60 rule, which is 60.
It's 60 minutes over 1 hour. Aren't they equivalent?
Oh, yeah, fair enough.
So that's why I can cross cancel the units. I do this so I can get the hours out and bring, so when I multiply this times this, I get this number. And what unit is left are the
I
minutes.
see.
Okay? I'm going to show it to you in their work. Okay, questions? Yes.
Is there any other way to represent that Mark is going faster?
Well, you could do, well, what do you mean any other way? We're showing it with 70. That's the speed.
Mile.
Oh, on the little diagram? No, not really. You could mention the speed. You could put 70. It's just something, this is only something to get us to realize that K is going to be equal to M. Right? K equals M. It's going to be an A equals B. And that's what they did. Like this distance, instead of writing D and D, they just multiplied across, multiplied, and set them equal to each other. Gotta move on. Okay, we are at 20 minutes, so I'm sorry, I gotta move on. All right, Joe and Lisa. All right, let's try this one. Joe and Lisa are 44 miles apart and start biking toward each other. Okay, so here's the scenario. Joe's traveling 6 miles faster than Lisa. I'll call this Joe and this Lisa. They're traveling toward each other. If he's traveling faster, I'm making his line bigger. Right? If Joe's traveling 6 miles per hour faster than Lisa, they meet in 2 hours. How fast was each traveling? Okay. Do we know what the total is? What is the total? We know that time-wise, they travel 2 hours, right?
44 miles.
44. So, what am I writing on the left of the boxes?
Joe and Lisa.
Joe, Lisa. Okay? I've got rate times time equals distance. Do we know Joe's distance? The 44 miles, where would that go? It's the total of both distances, so we have to draw that extra. Okay, what do we know? Rate looks a little, what do we know about the rate? Bryce?
So Lisa would be R, and Joe would be R plus 6,
Good.
because he's traveling 6 miles per hour than Lisa.
Okay, now tell me about the time.
The time would be, we don't know the time. Oh, 2 hours.
2. They both travel 2 hours and they meet. So multiply across. 2 times R plus 6. Multiply across 2R. Easier to do with one variable, huh?
Yes.
So it's 2 times the quantity of R plus 6 plus 2R equals 44. 2R plus 12 plus 2R equals 44. We get 4R. And we get 4R is equal to 32. Divide by 4. And R is equal to 8. So how fast was Lisa going?
9, 8.
8. And we are in miles per hour. Make sure you're using the correct units. And so what was Joe going?
12, 16, 14. I said all the numbers.
14 miles per hour, 8 plus. So you're going to say Joe is traveling 14 miles per hour. Lisa is 8 miles per hour. Questions? Okay. I'm going to pause it if you need to keep writing. I'm going to continue. All right. The next kind of motion problems are wind, are like wind and current problems. Yes.
How come in that one, Joe's arrow wasn't going more?
Further, I don't. It's just like a quick little sketch to show us it's going to be J quantity plus L quantity equals 44 quantity. Is basically, right? This is the J plus the L equals the 44. It doesn't have to be exact. It's not a perfect sketch. It shouldn't. You don't need to use an air. Excuse me. I'm tape recording. Okay. You don't have to use a ruler or anything. It's a quick sketch to just get it straight in your head. Because I don't look at these problems and go, oh yeah, I know how to solve that. I just start filling my boxes, and then I see what I have, and then I try and create the equation. Okay? So your goal every time is to create the equation. All right, so the next type is a wind and current problem. I like to use R. We're going to use R for the speed of the plane and W for the speed of the wind. Now, it is the same story if you are using water. When you're in the air and the wind hits the face, okay? That's called a headwind. If the wind is coming at my face, what's it going to do to me, the plane?
Slow you down.
It's going to slow me down and push me back, right? So if it's a headwind, it's going to slow us down. It's going to be minus, right? But if it's a tailwind, what's happening with the wind? It's pushing my behind and it's making me go faster. Now the same thing happens in the water, okay? In the water, when you're in the lazy river and you're going against the current, what's happening? Right, when you go against the current, you go slower because it's pushing you back. But when you go with the current, let's say you're in the lazy river, you're barely moving. There's the speed of your legs, and you're barely moving, and the water's also pushing. It feels like you're going 30 miles an hour. You're flying by everybody.
Like when you're on an escalator?
Like those walking.
Cut it. Here we go, back to it. Okay, so do you understand how water and wind move the same way? Now, you're going to have two speeds. The speed of the vehicle, the boat or the plane, and the speed of the wind or the water. Okay? So, a light plane flies, well, I'll use P, but normally I like you guys to use R. So you know what we're talking about. Do you understand? Because it's not just a plane. Oh, let's use R. Let's use R. I'll keep changing it. Okay. A light plane flies 1,200 miles with wind in 4 hours. So I'm going to label this with wind. And the other one would be against. Okay? Again, we're doing rate times time equals distance. A light plane flies 1,200 miles with the wind. So here's the plane. I also like these because they're very predictable. He's going 1,200. Okay? In 4 hours. The return trip, here's what he's doing. The return trip, what is that implying about rate, time, or distance? What does it imply about any of those three?
It's against the wind.
The return trip. The return trip. I go to school, I come home. All I want to know is in relationship to rate, time, or distance. Yes?
That you're going the same distance?
Same distance, going there and back. I go camping up the river. I go there and I come back. So My distance there and back is 1,200 because it says a light plane flies 1,200 miles with wind. So I'm going to put the 1,200 in here. And in 4 hours, I can put the 4 here. And how am I going to show that speed? What do you think? How about the speed of the plane plus the wind? Okay? Now, coming back, it's 1,200. How long does it take? More time, right? Because we're going against the wind. And what is the speed going to look like? What are we going to call that, Cameron?
R plus A. Wait.
I'm going against the wind. Go.
R minus W.
R minus the W. Okay? So those are your two equations. 4 times R plus W equals 1,200. And the other one is 5 times R minus W equals 1,200. Okay? I'm going to move on to the next page. Remember, they're using P, we're using R. You guys with me? Now, these are simple enough because 4 divides into 1,200. I'm going to divide it out. I get R plus W equals 300. Divide this by 5. Property of equality. R minus W equals 240. Okay, now what I can do, this looks perfect for R minus W equals 240. I can do my elimination. 2R equals 540. Divide by 2, divide by 2. R is equal to 270. Okay? So the rate of the plane equals 270, and I think we were miles per hour. And then I'm going to go back. Hold on, we're not done. I'm going to go back to either original, and I'm going to substitute in 270 minus W equals 240. Subtract the 270. Negative W equals negative 30. So W, multiply it by negative 1. W equals 30. My wind is 30 mph. All right. Boat problems. So do as many of the problems as you can. We're basically doing 1 through 14. So if you don't understand something, go on to another. You are responsible to get them all done. You better walk in with half the homework tomorrow. Okay? Oh, pause the recording. There we are. We're going to go with 1 through 14 on. If you did some even, I wouldn't be upset, but at least get to your 1 through 14. And that's our recording. We're on page 383, Green Book, 1 through 14 on.